On to the next unit. What we have here, it says simplify. It says in the first parentheses, for those of you on virtual, it says 3x to the second power plus x minus 4. And then after the parentheses ends, we have a plus sign. And then we have 2x to the second plus 2x minus 3. Now, let's talk about this 3x to the second, okay? That's a number times a variable. Now, the variable has a power of 2, but that's called a term, okay? When I have multiple terms, like I have 3 terms in this parentheses and 3 terms in that parentheses, these are each called polynomials, okay? Polynomial. And that's another polynomial. Okay, in this lesson we are just simplifying by adding and subtracting polynomials. Now, you don't make the 3 lines, okay? The reason why is because you have addition and subtraction signs. You did not have that in the last unit, okay? It was all multiplication, division. So when I have these plus and minus signs, okay, and then in between the parentheses we have a plus, that means it's a totally different ball game. So here's what you do. You look at what your highest power is, okay? The x, the variable I should say. That's x to the second, and that's x without a power, so it'd be x to the first, and then the 4 doesn't have an x. So, and that one has an x to the second, x to the first, and then no x at all. So the highest degree I have is x to the second. So put degree equals, and you just write your variable down and put x to the second, because that's your highest. So then when you add and subtract, it's just like combining like terms. So I go blank x to the second plus blank x plus blank, okay? And then it's just like combining like terms, okay? So x to the second, we have the 3x to the second, and we have 2x to the second. So all I need to do is add the coefficients, 3 and 2. 3 plus 2 makes 5, so we have 5x to the second. Then cross out what you just added, and then you find your x's. With that, those are the x to the first. Now I have this x right here, so I'm going to apply a coefficient of 1 in the front, so that's 1x. And this other x here has a 2, so I combine 1x and 2x, so 1 plus 2 makes 3. Okay, then these are called my constants. They're the numbers that are not multiplied by any kind of x, which would be -4 and -3. If they have minuses, they need to be added as negatives. So -4 plus -3 is -7, and that's your answer. Okay, simplified. X to the second, x, and the constant are not like terms, so they cannot be added. So that's as simplified as we can make this. Okay. Okay, my next problem. This is my first polynomial. 8c to the second is my first term, minus 4c is my second term, plus 1 is my third term. -3c to the second, plus, might want to put a 1 in front of your c there, and then plus 5. Now, you have a plus sign in the middle. Sometimes it's a minus sign, as we'll see on the next problem, but when it's a plus, you just leave everything the same and write what your degree is, and c to the second is your highest power. So I go blank c to the second, and we also have c's after c to the second, blank c, and then plus a space at the end. Okay, so c to the seconds. We have 8c to the second and -3c to the second. So we add 8 plus -3, and that's 5. Okay, now for the c's, I have a -4c and a positive 1c. So -4 plus 1 is -3c. Then my constants, I have positive 1 and positive 5. That adds to positive 6. So that's my answer, 5c to the second plus -3c plus 6. Those of you who have, yeah. Okay, now, next time, in the first parentheses, we have the first term is 10m to the second, minus 7m is my second term, plus 2 is my third term. Then we have a minus sign now, and then we have 3m to the second, negative 2m, and positive, minus 2m I should say, but we're going to think of it as a negative 2m and plus 5. Now, when you have a subtraction sign, here's what you need to do. You need to make it an addition sign, and then all three of these terms in the second polynomial, we change the signs. Not in the first, leave the first alone. So the opposite of positive 3 is negative 3. The opposite of negative 2 is positive 2. And the opposite of positive 5 is negative 5. So that's how you handle a subtraction. Then the degree is going to be m to the second. So I go blank m to the second plus blank m plus blank. So it's just like combining like terms. So I look for m to the second terms to be combined. So we have a 10m to the second and a negative 3. So you just add the coefficients. 10 plus negative 3 is 7. Then for your m's, you have a negative 7m and a positive 2m. So negative 7 plus 2 is negative 5. Okay, then the constants, positive 2, negative 5, that's going to be negative 3. There's my polynomial, my one I've combined them. Okay, now the next one. 2x to the third minus 5x to the second plus 1x plus 2x to the second plus 1x to the third minus 1. Now we have a plus sign, so don't reverse the signs in the second polynomial, just keep it the same. But the degree this time is x to the third, because the highest exponent the x variable to is to the third. So when I line up my spaces, it's going to be blank x to the third, followed by blank x to the second, followed by blank x. You're not going to see x to the first. X is x to the first. Again, x is x to the first. Then my constants. That last blank is for numbers that aren't multiplied by a variable. So I'm on the lookout for x to the third. So I have a 2x to the third in the first polynomial, and then a 1x to the third in the second. So I combine 2 and 1 by adding. That's 3. Then x to the second. So I have negative 5x to the second and 2x to the second. So negative 5 plus 2 is negative 3. So we have negative 3x to the seconds. Then for x, the only one I have is just this one. Okay, so if that's the only one I have, I just put 1 down. I don't combine it with anything. You can't combine this with this because that's multiplied by x, and that's just a constant. And then finally the constant, you'd have negative 1. And there's your answer, 3x to the third plus negative 3x to the second plus 1x plus negative 1. Okay, 3 more. In my first polynomial, I have just 2 terms, a 4n to the second and then a positive 5. Then in the second in the second polynomial, we have a negative 2n to the second plus 2n minus 4. So, again, make it plus, and then everything in the second polynomial goes opposite, not the first. Positive, negative, positive. Because you're subtracting that entire quantity, so then everything in the whole quantity gets changed. So the degree is n to the second. So it's just blank n to the second plus blank n plus blank. And then after I'm done with this problem, I'm going to go over a couple what ifs. Okay. So n to the second, we have 4 plus 2. Okay. 4 plus 2 is 6. Right there. Then n's. You don't have any n's in that polynomial, but in this polynomial you have a negative 2. Okay, so you just put a negative 2. Then for constants, you have a positive 5 and a positive 4, which adds to 9. Now, a couple things I'm going to talk about. You don't need to write this down. Let's say I write this out. Okay, this is a what if. Let's say I add the n to the seconds and I get 3. Now, let's say I add the two n numbers and it adds to 0. If it adds to 0, we don't put a 0 there. We just take out the term. okay, if it adds to 0. If it adds to 0. Because 0 times any variable is 0, okay? Or if there isn't like that at all, in another case scenario, let's say I'm dealing with m, blank m second plus blank m plus blank. Let's say I add the m to the seconds, and let's say I get 10. Then let's say I look for m's without the second power, m to the first power, and there aren't any at all, and I don't see any. Then that would also be a 0, and you'd take it out. Okay. All right, next one. In the first polynomial, we have negative 4m to the second plus 3m minus 1. And then the second polynomial, we have a minus, and then a 1m plus 2. So that minus, we make it positive, then every term in the second polynomial right after the minus sign switches, so negative and negative. So the degree here is going to be m to the second, okay? So blank m to the second plus blank m plus blank. So m to the seconds, we have negative 4 here, but we don't have any m to the seconds there, so it's just going to be a negative 4. Then m's, you got positive 3 and negative 1. Positive 3, negative 1 adds up to 2. Then constants, negative 1, negative 2, that adds to negative 3. Okay, last problem. 3m plus 4 in the first polynomial, minus, and then 2m to the second, minus 6m plus 5. So again, with this minus operator, we make it into an addition operator, and then everything in the second goes to opposites, so it'll be negative 2, then it's negative 6 goes to positive 6, positive 5 goes to negative 5. So the degree is going to be m to the second, okay? So blank m to the second plus blank m plus blank. So m to the second is going to be negative 2, because that's the only one I have. Then for m's, I've got a 3m here and a 6m here, so 3 plus 6 makes 9. Then numbers without m's, we have a 4 and a negative 5. Add those, it's negative 1. Okay, that's it.